Hello, welcome again. We are covering the topic centrifugal compressor for civil services mains IFS at Gate Aerospace exam. The next subtopic in the main topic of centrifugal compressor is TS diagram of centrifugal compressor. So this is your TS diagram of centrifugal compressor. So the vertical coordinate is T and horizontal is entropy. First of all, understand these lines. So these are the constant pressure lines. This is your P01 pressure line. So here the pressure is constant. This is your P2 line. Here the pressure P2 is constant. This is P03 line. Here the pressure P03 is constant. And here the pressure P02 is constant. This point represents the stagnation intake condition of centrifugal compressor. So at the intake, the stagnation temperature is T01 and stagnation pressure is P01. This point represents the final condition of the air at the exit of compressor. So T03 is the final, or T02 is final stagnation temperature, and P03 is the final stagnation pressure. And this process represents the actual process happening in the compressor. Okay, both in impeller and diffuser. So, and if we consider only the impeller, then this is the process representing the process in impeller. So here in impeller the pressure rise is from P01 to P02, and the stagnation temperature is final stagnation temperature is T02. And in diffuser, if there are losses, then only the pressure loss would be there. No temperature drop will be there. So temperature stagnation temperature will remain constant, and this will represent the pressure loss from P02 to P03. Okay. Only the pressure drop will take place. Stagnation temperature will remain same. Okay. So here we have taken stagnation condition, and here we have also taken stagnation condition. Here we have also taken stagnation condition. But the actually at the exit of the impeller there is some velocity of air. So static condition exists at the exit of the impeller. Okay, so as these are stagnation conditions, so if we decrease this dynamic temperature from the total temperature, then we will get the actual condition at the exit of the impeller. So these are the actual condition at the exit of impeller. So here the temperature is T2, and here the pressure is P2. Okay, this is corresponding to pressure P2 and temperature T2. Okay, so now this is the process occurring in both diffuser and impeller. Overall process. This is the process in impeller. Okay, and this is the line to find out static temperature from stagnation temperature, or stagnation condition from the static condition from the stagnation condition. Okay. So now if the process is isentropic, okay, then corresponding to pressure P03, T03 dash would be the temperature. Okay, but actually the temperature is T02 or T03. But if the process is isentropic, then the temperature would have been T03 dash. Okay. So this represents overall loss. So this is the extra temperature rise in the compressor. Okay. So from T03 dash to T02 or T03. Okay. If the process in the impeller is your isentropic, okay, and then the pressure rises from P01 to P02, okay, then the isentropic temperature would have been T02 dash. Okay. So this will represent your impeller. So and this will represent your diffuser loss. Okay. So these are the losses in impeller, because corresponding to this point the pressure would have been somewhat else, and corresponding to this point the pressure is less, pressure is somewhat less, and corresponding to this point the pressure is further less. So this represents overall loss, this represents overall loss. Okay, and this represents impeller loss, this represents your diffuser loss. Okay. So now reading out the main points. So here P01 and T01. This point represents intake, stagnation pressure and stagnation temperature. Okay. And P2, T2. So this point represents the static conditions or static pressure and static temperature at the exit of entry. P02 minus P01 is stagnation pressure rise. P02 minus P01 is stagnation temperature rise. So stagnation pressure rise in impeller. P03 minus P02 is your stagnation pressure loss in diffuser. P03 minus P02 is stagnation pressure loss in diffuser. T02 T is equal to T03 is stagnation temperature at the exit of impeller and diffuser. Both are same. There is no temperature stagnation temperature rise in the diffuser. Static temperature rise there, but stagnation temperature remains same. So this is the stagnation temperature at the exit of impeller at diffuser. T02 dash is stagnation temperature at the exit if the process is isentropic in impeller and diffuser, and pressurized is T02 minus T01. So here T02 dash is isentropic, T02 minus T02 dash minus T01 is isentropic rise in temperature when the final pressure is T02. And last one is T03 dash stagnation temperature at the exit if the process is isentropic and pressurized is P03 minus P01. So this is the isentropic temperature or isentropic rise in temperature if the pressurized is P03 minus P01. Okay. So these are the various losses in centrifugal compressor and TS diagram of centrifugal compressor.